So a system of equations in two unknowns can be solved in a variety of ways without a graphing calculator, and I typically do not turn to graphical means. It's because real-world problems don't tend to turn out to be whole number answers, and I have to set up an appropriate window to do that. So there are so many other ways to solve a system of equations. One of them is by the substitution method. These are algebraic ways, and the other is the addition method or the elimination method. We're going to focus on those two methods in this next unit. Substitution being very, very, very handy in science. And so this is a very heavily applied topic in our sciences, especially physics, statics. So I'd like you to have in your tool belt all kinds of ways to do that. So let's focus on the substitution method. So step one is to isolate one of the variables in one of the equations. Would you look with me at this first system? Do you see how y is all alone? That means isolated. It's already all alone. Step number two is to substitute the expression from step one into the other equation. So you see how y is equal to this expression? Step number two is to substitute that in for y into the other equation. And then solve that second equation for the variable that's left as a result. So what I'll do, the second equation still has an x, but it's got 2 times y, but y is x plus 2, so I'm going to substitute in an x plus 2 for y, and I'm going to solve the second equation for the remaining variable, in this case is the letter x. So I have 1x plus 2x plus 4 when I distribute these. I have 3x plus 4 equals 7. I'll subtract 4 from both sides. I'm running out of space. So I'll have 3x equals 3. And then when I take 3x equals 3 and I divide both sides by 3, I'll have x equals 1. Step number 4, substitute the value that you just found for x in this case and put it into the first equation right here, the y equals x plus 2. Now you could put it into either equation, but the first equation you had isolated y and you found out that it was equal to x plus 2. So now to find y you could substitute in a 1 for x, add 2 to it, and get 3 for a solution. Please state your answer as an ordered pair. So x is 1, y is 3, and then would you always remember to check your answers for x and y into the original equations. So in the first equation it's y equals x plus 2. So for y I'm going to put in a 3. For x I'm going to put in a 1, and sure enough that checks. The second equation is x plus 2y equals 7. So for x I'm going to put in a 1. For y I'm going to put in a 3. And I'm going to ask myself if 1 plus 6 is equal to 7. Sure enough, I know I got this problem correct. Substitution is just really, really an awesome method. So in these two equations, the only one that has a letter that has just a 1 in front of it is the second equation, which has a 1 in front of the x. I don't bother with substitution unless I can isolate a letter without any fractions involved. So what I have here now is the letter x is equal to 7 plus 3y. So I have isolated x. I've gotten it alone, and I don't have to deal with any fractions. So I'm now going to take this expression and substitute it in for x, remember, in the first statement. So it's 5 times that. So 5 times x, which is 7 plus 3y, plus 6 times y equals 14. And here I'll get 35 plus 15y plus 6y equals 14. And on the left hand side I'll have 21y plus that 35 over here. And let's subtract 35 from both sides. So I'm going to subtract 35 here from both sides. I believe that 14 minus 35 is a negative 21, and I'll divide both sides by 21, and I'll find out that y is equal to a negative 1. I'm going to put this value for y is equal to a negative 1 into equation 2 because it's got the x in it. I could also put it into this right here. The only thing is if you put it into this right here, so this is a version of equation 2. So if you put it in there, you created this statement right here, so you've got to be sure to check it. So I put in a negative 1 for y, and I have 7 plus a negative 3, which is 4. So my answers, x is 4, y is a negative 1. I really should take the time to check that. And I'm looking at my notes. I have checked it before, so I'm not going to do that right now, especially I've run out of a little bit of room. Let's go ahead and do another couple of problems. We can fit 2 more in here before we're done. So in number 3, the letter T is isolated. It is equal to 4 minus 2s. So right there, I'm going to put in for T, I'm going to put in 4 minus 2s. However, I have a plus 2s right there as well. And when I collect these like terms, a negative 2s and a positive 2s, they add to be nothing. So the s's are gone, and I have a statement that's called 4 equals 6. Oh my. 4 does not equal 6. There is no solution to this problem. If you were to graph this problem in the rectangular coordinate system, now I've got to be careful, I'll try to graph one of them correctly. So this one right here, the y-intercept is a positive 4. And the slope is a negative 2, so I'm going to go down 2 and over 1 and down 2 and over 1. So this is kind of an approximation of the graph of the first. If I were to graph the other one, it looks to me like it would be just above it and parallel. So the reason there's no solution is because the two equations have a slope of a negative 2s, and they would never intersect. We also say sometimes that this is an inconsistent system because it has no answer. In the next one, please notice when there's no solution, you get a statement that is not true. In this next problem, when I use substitution, let's see, I'm going to go ahead and take, I think, this second equation and solve it for y. So I'm going to add 4x to both sides in an effort to get the 2y alone. So I will have 2y equals, if you don't mind, I'm going to put the 4x first and then the 5. And now I'm going to divide both sides by 2 to isolate the letter y. Now, I got to tell you, let's see, 4 divided by 2 is no problem. But 5 divided by 2, which is 2.5, or 2.5, I don't particularly care for using substitution for this one, but it's not all that bad. So I'm going to take this expression. Remember, I used this equation to get this expression, so I got to go into the first equation. I got to put 6 times this binomial right here. So I'll come on over here, and I've got 12x minus 6 times the binomial, which is 2x plus 5 over 2, equals that negative 15. And when I distribute this, let's bring the 12x down, there I'll get a minus 12x. And a negative 6 times 5 over 2 is a negative 30 over 2. Negative 6, which is 6 over 1. 6 times 5 is 30 over 2. I'll have no x's left, and I will have a negative 15 on the left and a negative 15 on the right. When you have a true statement and you lose the letters, it means that there are many solutions to this problem, and the graphs of these two equations lie right on top of one another. They don't intersect and you get that spot. The graphs of these two equations, one would be like this and the other would fall right on top of it. Again, many solutions when this statement results. I'm going to pause and we'll do some story problems in the next segment.